Hi guys, my name is Tomasz Drwięga. So yes, I'm gonna be talking about building the tech to power blockchains, which is pretty much the overview of what we do at Parity Technologies. So maybe a first question before I go into describing this slide. How many of you know about Parity Technologies already? Okay. Okay, that's great. That's why we have this presentation. What we do is we are a team. We are a company that builds blockchains. So our endeavors can be divided into this like 3 major blocks. So our main focus is on building core technology that powers blockchains. Then we build some developer tools and some building blocks that can be used to build decentralized technology. And we have a couple of end user products that are that you can install and use on your computer without being an expert on blockchains. So yeah, if we go into the core technology that we are building, our main product here is something that is called Parity Ethereum, which is an Ethereum client. How many of you know about Ethereum here? Okay, so yeah, Parity Ethereum is, I think it's a second major client. It has been built in 2016. Was the 1.0 release. The first largest client is Go Ethereum, which is developed by Ethereum Foundation. And here with Parity Ethereum, we try to build. We have tried to build a client that is faster than GEF and also has some unique features that I will go briefly into on my next slide. We have also built a Bitcoin implementation, and it's a Bitcoin client that you can use to sync all the blocks. It's compatible with the main Bitcoin client, and the cool thing is that it doesn't really use libBitcoin, so the thing that has the consensus thing. We have rebuilt everything from scratch in a language called Rust. And our new products that we are working on heavily right now is a technology called Polkadot that I will introduce briefly in my next slides, and something that is called Parity Substrate, which is a framework to build blockchains. Because as you can see, we have built a blockchain client at least 3 times, so we have figured out that it's a time to build a framework to build blockchains if we are going to build more. In terms of developer tools and building blocks, we have some JavaScript libraries for UI developers, 007 and Light.js. The other thing that we are building is a library called libp2p, which is a library for peer-to-peer communication. Next thing, WebAssembly. So we are really huge believers in WebAssembly in general, and we have built a WebAssembly interpreter in Rust, and also some tooling around it. I will dive more into why we did it a little bit later. And 2 other products that we have, it's Parity Bridge and Secret Store that I'm not gonna go deep today, but feel free to ask me after my talk. And our end user products, pretty much right now, it's Parity Signer, which is a hardware wallet that is on your old phone, so you can install an app on your old phone and use that old phone as a hardware wallet, secure hardware wallet that you never connect to your computer, but rather you scan QR codes one way and the other to sign transactions securely on the phone. And Feather, that I think Thibault will talk a little bit more about, so I'm not gonna go into details here. Yeah, in terms of technology, pretty much everything that we are building Especially the core tech is built in language called Rust. How many of you have heard of that language? Okay, cool. Couple of people. I'm gonna have a couple of slides why we use Rust and at the end of my presentation. The JavaScript libraries I'll build in JavaScript, obviously, and TypeScript. And the products, the end user products, are in React and React Native. Who are we? We have been, like, the company started in the end of 2015. It has been started by, in a large part, by a team that was responsible for C++ client for Ethereum. So guys were building C++ client for Ethereum as part of Ethereum Foundation, and then at some point they have decided to start a new company, and that have become Parity Technologies now. Currently we are over 60 people. It's mostly developers, so 45 is like a rough figure of the number of developers that we have. Mostly Rust developers as well. We have a main office, like development headquarters in Berlin, and also an office in London, and we are opening an office in Cambridge pretty soon. Obviously, we have a lot of developers working remotely, me included. I work remotely from Poland, but we also have people working in China, in Russia, in the United States, and pretty much all over the world. The company is running in this programmer anarchy model, so we don't really have a lot of management, sprints, and scrums. Like, the idea is you work on what you want to work on. We just try to bring the company vision to fruition in short term. Yeah, so let me go more into the core technology that we are building. And our main client, as I said, our main product, as I said, is Parity Ethereum client. The idea for Parity Ethereum was to, as I said, the initial team has already built an Ethereum client in the past. It was C++ client, so they already know, they already knew what things went right and what went wrong. And the idea for Parity Ethereum was to be a really modular and kind of composable client that you can use not only to connect to Ethereum main network, but also to build your own private chains with that client. So for that we have a pluggable consensus engine. So we can run proof of work chains and also proof of authority chains. With Proof of Authority Plus, I mean that we also support many on-chain based solutions for managing validator sets, managing block rewards, and we support EVM as an execution environment for smart contracts, so the thing that is used by the Ethereum main network. But we are also experimenting with WebAssembly here. So the idea is that you can write smart contracts in WebAssembly and have them executed on-chain. And currently on our Kovan testnet, we support both EVM and WASM, and they can also interoperate. So you can write a smart contract in Solidity, compile it to EVM, and then call from that contract to a WebAssembly contract, and it's gonna execute inside WebAssembly execution environment and return some results for this EVM contract. Obviously, we support multiple chains, public chains and also private chains, and we have a couple of custom features that are built, on top of the Ethereum spec, such as private transactions. So you can send a transaction that executes a smart contract, but the data is not really public to everyone in the network. It only affected parties actually execute and can read the result of the contract execution. And a couple of custom RPCs to interact with the client. So some notable projects that we have built on top of Parity Ethereum, so they are using the Ethereum client in Wild. Like the main project is a project with World Food Program. World Food Program is funded by United Nations. And the idea is that there is a blockchain there. Currently, it's not super decentralized and not super like permissionless, but they are planning to open this up in the future. And that blockchain is responsible for distributing help to refugees in Jordan. So the WFP receives donations. Those donations are transparently recorded on the blockchain, and this money is distributed to the refugees. Refugees can use that money to pay for food and for all the things that they need by paying the merchants, and then merchants can get real money back by kind of exchanging those tokens in World Food Program. The second big project that we are building on top of Parity Ethereum is a project together with Energy Web Foundation. They are building a blockchain to open up energy market, which is currently really closed. So we have a testnet for this, and they are utilizing the features that we have built in Parity for pretty much for enterprises like private transactions and transaction permissioning to meet this requirements of energy sector. So the vision that Energy Web Foundation has is that we're gonna live in this like peer-to-peer energy market where your fridge can buy energy and, for instance, store it inside some battery, and then when the energy is more expensive, it can actually sell it back to the network, so it can do arbitrage on the energy prices. And it's going to be all done transparently on the blockchain. Our next big project that we are super excited about is called Polkadot, and why we are building Polkadot in this first place is the interoperability. So currently we have many blockchains out there in the wild, like Bitcoin, Ethereum, and all others. Just like open CoinMarketCap and you will see like thousands of projects there. But the main issue is that they are not able to communicate with each other. So they are all decentralized, transparent, and trustless, but there is no way to send a Bitcoin transaction that will execute an Ethereum smart contract, and that Ethereum smart contract could possibly control those Bitcoins on this other chain. So with Polkadot, we are trying to build kind of like a higher level network that will enable multiple chains to communicate with each other. So connecting existing networks is like a really future goal. What we believe in a shorter term is to have something that is called a relay chain. So another blockchain that is this kind of like a top blockchain, and then a way to create new blockchains that are connected to this relay chain. And by connecting to this relay chain, they not only get a way to communicate with other chains that are connected, we actually call them parachains because they can execute stuff in parallel, but also they can use the pooled security of the relay chain. So every parachain that you can create doesn't need to have its own miners or its own stakers. They can just use the same security that is provided by the relay chain. And the idea of building multiple blockchains is that every blockchain can do one thing really good, right? So currently we have Bitcoin for payments. We have Ethereum, which is like super general smart contract execution platform. But maybe we need more specialized chains that have different models, that have different trade-offs, but still wants to be able to communicate with these other chains to kind of leverage the good things that the particular blockchain has. Yes, and the idea is that parachains can actually process transactions in parallel, so you also get this nice scalability feature that we don't have this kind of a drawback of blockchains currently, that every transaction has to be processed by every node in the network. Here, parachains can run separately, and the only thing that we need to agree upon is this relay chain, and whatever happens on that relay chain. Yeah, and I'm not gonna go more into details of this. We can talk later, or I really recommend to read the white paper of Polkadot. And yeah. And then the last thing from the core tech that I would like to briefly talk about is Parity Substrate, because this is kind of like a side effect for us of building Polkadot. Because as I said, we have already built a couple of blockchain clients in the past. Like guys have built the C++ Ethereum client, then we have built Parity Ethereum client, then Parity Bitcoin, and now we have started to work on Polkadot. And we figure out that there is a lot of similar things that you have to do whenever you are building a new blockchain, even if they're a little bit different. So we have actually extracted a lot of stuff from Polkadot into a framework which we call Parity Substrate. And the idea with Parity Substrate is that if you want to build your own blockchain that potentially might be part of the Polkadot network in the future, you don't really need to focus on doing networking or doing the consensus stuff, which is pretty much the boring stuff that you just have to have for a blockchain. But you can focus on whatever is unique to your particular blockchain. So the state transition function between one block and another. And for this, we have a couple of runtime modules that you can actually use. You can like pick and choose some of the runtime modules to kind of like compose your own blockchain, or you can write everything from scratch, and that's also fine. A couple of unique features that we have in our framework is that the runtime is actually written in Rust, all the runtime modules. So you can compile them natively to like machine code and run them at native speed. But we can also compile them to WebAssembly. And what this enables us is you can upgrade your blockchain, so you can change some rules in your blockchains, but you don't really need to force everyone to update their clients so that they have the new, Rust version that is compiled to native. But you can publish the code of WebAssembly on chain itself, and the node will actually pick up the WebAssembly code that is stored on chain and will start execute like beginning of some block will start to execute the WebAssembly, like interpret the WebAssembly instead of going and running the native that you have. So the cool thing is that you don't really need to upgrade. If you want to upgrade the chain, you don't need to upgrade the client. You upgrade the client because you get this nice effect of greater performance because you run native code instead of you interpret WebAssembly. Yeah, and when building Substrate, we actually have like 3 different ways how you can use our framework. So you can either use something that we call Substrate node, which is like a complete binary that you only configure with a JSON object, and you say, I want this module with this parameters, that module with that parameters, and you start a new blockchain just by providing a JSON with parameters. Or if you are building something more advanced, then you will probably have to change the runtime, so you can implement some new runtime modules that can that are this unique state transition function that your blockchain has. Or if it's not sufficient because it's more opinionated, like the higher you go here, the more opinionated you have, the more opinionated node you have, because this is what we believe it should be possible to configure. But you can also go lower in the stack, and you can use something that is called Substrate Core, which is just basic networking, basic consensus. You can choose from different consensuses that we have implemented. You can choose different crypto storage, so you can have like a Patricia Merkle tree like we have in Ethereum, or something a little bit simpler. And you get RPCs for free as well. Yeah, so it's pretty flexible to whatever you want to build.
Can I have a quick question?
Sure.
Regarding for the effortless upgradability of WASP, can you give me a rough idea what's the advantage over like Oracle, or how it is compared to?
Sorry, say again?
You mentioned about the contract upgradabilities, and it interacts with like outside the world, not just living in a blockchain, is it?
The contracts.
Yes, I mean.
Okay, so like the thing here is that smart contracts is just one part of the runtime.
Yeah.
So the runtime can allow you to deploy smart contracts or not.
Right.
But also the fact that your blockchain supports smart contracts is something that you can upgrade to.
Yeah.
Right? So you can start your blockchain without smart contracts, and then at some point you say, oh, my blockchain actually should have smart contracts, so I take this module that we have, you compile the new runtime version, you publish this new runtime version on-chain in WebAssembly format, and then all the nodes start executing smart contracts at some point. So here I'm not talking about smart contract upgradability, because that's something that is, even higher level. I'm talking about low-level option to actually run smart contracts or not, and that's something that you can upgrade from. If you want to have upgradable smart contracts, then that's something that you can implement inside this runtime module or in your own contract. Like for instance, like we have in Ethereum, right? There is this upgradability pattern that you can implement, and it's totally fine to do it here. But yeah, Substrate is more about the blockchain itself and how it can upgrade to have such functionality. If that answers your question. Okay. I said earlier that everything that we build in this core technology layer is built in Rust. And why Rust, you might ask? So when we were starting, it was a bunch of C++ developers trying to re-implement Ethereum for the third time, I guess, in C++. And one of our friends was really into Rust. He was researching that. He actually started to write some of the crypto primitives that might be needed for building blockchain clients. And he pretty much convinced us to try Rust for the Ethereum client that we were building. Of course, none of us had any experience with Rust when we started, but we learned along the way. And we grew together with the Rust community as well. So Rust has been changing a lot through this last 3 years. We obviously had to implement a few things ourselves. So if you start with C++, you get plenty of libraries that you can just use, and they work. In Rust, the ecosystem is pretty young, so a lot of things had to be built in-house. But we are still really happy with the choice. So the reasons are. Rust gives us a great performance. We could use some higher level language with garbage collection, but when you are building a blockchain and when you are processing all the transactions that are happening out there on a shitty laptop that you have in home, then you really need this performance that's the best performance that you can pretty much get from the hardware. So. Yes, obviously you can implement that in JavaScript, but it's gonna be slow, and it's probably won't be able to keep up with the rest of the network. So by implementing that in Rust, we have this great performance, and also Rust has this zero-cost abstractions, so we don't really need to optimize, pre-optimize some stuff, but we can introduce abstractions as much abstractions as we want, but Rust will compile it down to a more monomorphized version, and it's gonna be faster anyway. No virtual calls. So yeah, we didn't have any concurrency issues, any data races. We had a few deadlocks because this is something that Rust doesn't protect you from. But we didn't have any issues with concurrency, and our applications, as you may imagine, are really heavily multi-threaded, and yeah, it was really awesome that you don't have to debug any data rates or anything. Rust is supporting WebAssembly. What I mean by that is that you can compile Rust to WebAssembly, and this is something that we also looked into. Unfortunately, there was no WebAssembly interpreter or JIT in Rust, but we have built one ourselves. And yeah, surprisingly, hiring really good devs in Rust is really easy, because if you have a Rust programmer, it's a guy that have learned Rust, even though there's not much job offers for it. So he's a really usually he's a really good programmer that devotes his free time to learn a new language, and yeah, we were really happy with that part as well. And yeah, what we see in the future for Parity and the stuff that we are currently working on, day to day. We are planning to have some smart contracts DSL in Rust for WebAssembly contracts. That is we hope that it would be cool to have it focused on safety and security of smart contracts. We have our own WASM interpreter, and there is a lot of room for optimization there. And because we use that interpreter to run WASM contracts or the runtime, it's really important for us to do that as well. And some security tooling for Rust smart contracts would also be pretty cool. We want to use libp2p for Ethereum. Ethereum currently is using a different peer-to-peer library called devp2p. Which has its flaws, so we believe libp2p is much better choice. So it would be interesting to have Ethereum with libp2p in the near future. If we implement that would enable us to actually run Ethereum client inside the browser. So compile Parity Ethereum to WebAssembly and run it in the browser. And the really awesome thing about it is that currently, if you are using Ethereum dApps, they require you to install MetaMask extension, and they probably talk to Infura, which is like a centralized service. If we can compile Parity Ethereum to WebAssembly, you can have a website that has a light client embedded and can speak to other peers in a completely decentralized fashion without this third-party centralized server. And yeah, obviously some UIs for Polkadot and Parachain, so this really generic stuff that can be applied for any blockchain, for instance, and yeah, and many more stuff. Yeah, so that would be pretty much it from my side, and maybe you have any questions. Why do it?
Why do it if it's that slow?
Oh yeah, upgrading the network is a really complicated process, and coordinating every participant in the network to upgrade their software is also super complicated. And even though we are running slower, at least we don't fork the network, we don't have any consensus issues. Plus, we believe that it's something that we can optimize in the future, and the whole point with WebAssembly and with choice of WebAssembly is that EVM for Ethereum is a language that is specific to Ethereum blockchain, right? So the only people working on that is people who work on Ethereum blockchain. When we use WebAssembly, there is plenty of other applications for WebAssembly, so there's way more people working on optimizing WebAssembly, and we are just benefiting from that because we use the same technology. So if we see a similar kind of browser war that happened with JavaScript, between Firefox and Chrome, that they were releasing faster and faster version of JavaScript interpreters. If we see something similar for WebAssembly, we would be like super happy to actually see that and benefit from that.
Would you use your own? You mentioned you write your own WASM.
Yes. So currently we are using the Rust implementation that we have. We could link C++ WASM JIT that is out there, but there are a couple of reasons why we use our own implementation. For blockchain specifically, what you need is determinism, and WASM with floating points doesn't really have that. And we also need a really initially we need a way to measure how long the contract execution takes, so like, you know, inject some metrics. There are other ways to do it that would benefit from using JIT as well, but currently we are going this, you know, easier way, I would say. And also, like, Firefox is being rewritten to Rust, and we are actually in touch with Mozilla on the WASM thing, and maybe there's going to be some collaboration on the Rust implementation as well.
Okay, there was an acronym, proof of A+. Was that A+?
Oh, it's a proof of authority, and the plus means that we support many kind of variations of proof of authority, because you can have a proof of authority with a fixed list of validators, or you can have the list managed by the contract on-chain. And then, because it's a smart contract, you can build any governance model around it and any way how to change that list in the future. And yeah, we also support many ways to distribute block rewards. So it doesn't have to be hard-coded in the code that the block reward is like, I don't know, like 2 Ether or something. But you can actually call a contract on-chain again that will tell the engine like what the block reward for that particular block should be. And this enables you to do really crazy stuff with block rewards, for instance. Yeah. So that's the plus thing.
Are you planning to support SIMD and multi-threading in your interpreter as they become available in WebAssembly?
I can put you in touch with Sergey from our team, who is working on the interpreter directly. But I'm pretty sure that whatever bring us more performance, we're gonna implement that. But is it part of the WebAssembly spec already, or?
If not, it's being finalized.
Okay, so then yeah. I'm pretty sure we're gonna implement that.
And how do you compile down to WebAssembly? Do you use Unscripten or?
We actually use Rust compiler. So Rust compiler can either target Mscripten, and we did use that in the past. But currently, you can actually use Rust compiler to compile directly to WebAssembly. And this
is the LLVM WASM backend.
Yeah. Yeah, you obviously you are running with in no standard environment in Rust, so you don't really have standard library at all. But for smart contracts, it's fine.